Okay, last example. This is going to correspond to example 4 from 6.3 if you want to take a look at the solution in the textbook. Okay, we're going to do tangent 3x plus secant 3x equals 2. Okay, so again, a challenge here is that we have two different trig functions going on. We don't have any identities that relate tangent to the first power to secant to the first power. However, we do have a Pythagorean identity that relates tangent squared to secant squared, right? So I'm thinking that if we square this equation, we're going to be able to rewrite one of these functions in terms of the other one. However, before I do that, if I square both sides of this equation the way that it is now, notice that if I square this left-hand side the way that it is, now that means I'm going to have to write this out twice and then FOIL. And when I FOIL, I'm going to get a tangent secant and a secant tangent. So that'll give me two tangent secants. And I can't rewrite those. I can't rewrite tangent in terms of secant. I can only write tangent squared in terms of secant squared. So a better thing to do would be, before I try to square both sides the way that it is now, is move one of these things over to the other side. And it doesn't really matter which one. I'm going to move the secant over to the right-hand side first. So I'm going to say tangent 3x equals 2 minus secant 3x. Because now you see, when I square both sides, I'm just going to get a tangent squared 3x on the left-hand side. On the right-hand side, I'm going to get secant squared 3x. I'm also going to get some secant to the first powers of 3x. But that's okay, because I can come back over here to the left-hand side and rewrite the tangent squared in terms of secant squared, and then everything will be written in terms of secant 3x. Okay, secant 3x or secant squared 3x. So let's go ahead and square both sides now. Oh, I could use a different colored ink, maybe. Make it a little more clear, perhaps. Okay, squaring both sides now. So I've got tangent squared 3x equals. Now here, to square this side, like I said, you're really thinking about writing this out twice, right? And then foiling. So you get 4, negative 2 secant 3x, negative 2 secant 3x. Together that's going to make negative 4 secant 3x. And then here you're going to get positive secant squared 3x. I don't know if you can hear my kids making all kinds of noise. By the way, I'm actually in my son's bedroom, because this is the only place I can kind of sequester myself while I'm recording these videos. Anyway, all right. So now you see the right-hand side is all in terms of secants and secant squareds. The left-hand side is not, but I can fix that pretty easily, right? Because I know that tangent squared is the same as secant squared minus 1. So now I can just call this guy secant squared 3x minus 1. And now you see everything is in terms of secant, or secant squared, or whatever. Actually, now look at how nice this is, because when I move this guy over here, those terms cancel. Whew. Very beautiful. Okay. So I'm going to add this term over to the other side. I'm going to add this term over to this side. I'll end up with 4 secant 3x equals 5. Divide by 4. Use a reciprocal identity. Apply your handy-dandy rule. Okay. Now 4/5 is not, like cosine inverse 4/5, that's not an angle that we have memorized. So I'm going to have to use my calculator here and see what cosine inverse of 4/5 is. Okay, that's about 0.644. So 2 pi minus that is about, it's about 5.640. Excuse me. Okay, let's finish solving for x. So we would divide through by 3. And there you have it, right? That's all of the solutions. Well, actually, maybe not. That might be too many solutions now that I think about it, because, hey, look up here, we squared both sides, right? Anytime you square both sides of an equation, you have a possibility that you've introduced some extraneous solutions. So some of these solutions might be extraneous. In other words, they might not actually be solutions to the equation. So we're going to have to plug these in to see which ones work and which ones don't. So let me come up with a list of possible solutions that live in the interval from 0 to 2 pi. Okay, so we'll make a list of the possibilities, and then we'll throw away any of them that don't actually work. Okay. But let's see. If I plug in 0 here, I'm going to get 0.215. If I plug in 1, I have 0.215 plus 2 pi over 3. That's about 2.309. If I plug in 2, I get about 4.404. And if you're wondering where you should stop when you hit 2 pi, which is about 6.28 or whatever. So let me try plugging in 3. If I plug in 3, I get 6.498. It's too big. Okay? So that does it for this set. Let's look at the ones generated by this set. Definitely 1.880 is going to be in there. If I add 2 pi over 3, I get 3.974. If I plug in 2, then I would have to add 4 pi over 3. That would bring me to 6.069. And I have a feeling if I try to go any larger than that, I'm going to fall outside of 2 pi. Okay, so this is my list of possibilities. I have to plug these back into my original equation, right? To this original equation up here to see which ones work and which ones don't. I'm just going to use my calculator for this, okay? So let's see. I'm going to do tangent of 3 times 0.215 plus secant, right? That's 1 over cosine of 3 times 0.215. That comes out to just over 2. I'm not getting exactly 2 because, of course, I've done some rounding here. But I think this one works. Right? This one works. Let's try 2.309. So I'm going to go back and just replace the 0.215 with the 2.309. That one's also giving me 2. I'm going to try the 4.404. That one's also giving me something pretty close to 2. Maybe I don't have extraneous solutions. Or maybe it's the other set that was giving me the extraneous solutions. 1.88. Let's try the 1.88. Oh, that's giving me like 1/2. That's not even close. And based on that, since these other solutions came from this rule, I'm going to guess that they're also extraneous. Okay? I guess to be on the safe side, you'd really have to check them, right? But my final answer is going to be okay. So 2.215, 2.309, 4.404. And there it is.